Hi students, welcome to JSR Maths Academy. Now we are going to discuss about associative properties of rational numbers, and in that we are going to discuss about the first property, that is of associative property for addition. Okay, associative property for addition says that for any three rational numbers a, b and c, a plus of b plus c is equal to a plus b plus c. That means if you take any three rational numbers, while doing the addition of three rational numbers, even if you change the group, then that result will not change. That result will be remains the same. That means while doing addition of three rational numbers, if you change the group of the numbers and adding, then that result is remains the same. Okay, here we in this LHS part we have taken this B and C as a one group, and that is an association, and in RHS we have taken A and B as a one group, that is as an association. Even if you change the association of the numbers, then that result will be remains the same. Okay, this is what associative property for addition. Okay, let us see an example. Let three rational numbers that are a is equal to minus 2 by 3, b is equal to 3 by 5, c is equal to minus 5 by 6, then a plus of b plus c, a plus of b plus c. That means firstly we need to add the numbers which are in the bracket, that is of b plus c, and for that sum we need to add a. So in the place of a, I can write minus 2 by 3 plus 3 by 5. That means b means what? 3 by 5 plus of minus 5 by 6. This is equal to minus 2 by 3 plus, as these two are unlike fractions, LCM of these two for denominators is 30. LCM of 5 and 6 is 30. So to make this as a first fraction with the denominator 30 multiplied by 6 by 6, and second fraction should be multiplied by 5 by 5. So 6 into 3, that is of 18. That means 2 by 3 plus 18 minus 5 minus 5 into plus 5, that is of minus 25. So 18 minus 25 by 30, that is of minus 2 by 3 plus 18 minus 25, that is minus 7 by 30. Now these two are unlike fractions again, multiplied by 10 first fraction, so that you get it as a minus 20 by 30 plus into minus minus. That means you can write, let me write it here, minus 2 by 3, then if you multiply it by 10 by 10, and here plus into minus minus 7 by 30, then you get it as a minus 20 by 30 minus 7 by 30. These two are like fractions. Now write common denominator 30 and add the numerators, that is of minus 27 by 30. You get it as a minus 27 by 30. That means a plus of b plus c is equal to minus 27 by 30. In the same manner, if you take a plus b plus c, that means firstly we need to add a and b, and for that sum we need to add c. So 2 minus 2 by 3 plus 3 by 5 plus of minus 5 by 6. LCM of 3 and 5 is 15. So multiply this as by 5, multiply by 3 by 3. So you get it as a minus 10 plus 9 by 15 plus of minus 5 by 6. This is of minus 1 by 15 plus of minus 5 by 6, and adding them again you are going to get as a minus 27 by 30. That means the a plus of b plus c is equal to a plus b plus of c. That means on changing the group of the numbers while adding, that result is remains the same. After changing the groups also you get a remaining same. That's why we say that collection of rational numbers follows a associative property under addition. Okay, here you need to understand that association means what? Group. If you change the groups while performing an operation, if result is remains the same, then we can say that rational numbers follows associative property under particular operation. Here collection of rational numbers follows associative property under addition. And let us see about subtraction. Okay, for subtraction, okay, for any three rational numbers a, b, c, a minus of b minus c is not equal to a minus b minus c. That means if you change the group of the numbers while performing the subtraction, that result will not same. Okay, result is not same. If your result is not same, then we can say that collection of rational numbers does not follow the associative property for subtraction. Okay, let me explain this with a simple example, that is of a is equal to 2 by 5, b is equal to 1 by 5, c is equal to 4 by 5, a minus of b minus c. That means firstly we need to subtract b minus c. So a minus means 2 by 5 minus 1 by 5 minus 4 by 5, and subtracting it you will get 2 by 5 minus of minus 1 by 4, sorry, 2 minus of 1 minus 4 by 5, that is of 2 by 5 minus of minus 3 by 5, minus into minus plus, that means 2 by 5 plus 3 by 5, which is of 5 by 5, you get as a 1. That means a minus of b minus c is equal to 1 you will get, and a minus b minus c, that means 2 by 5 minus 1 by 5 minus 4 by 5. So on subtracting these numbers which are in the bracket, 2 by 5 minus 1 by 5, you will get a 1 by 5. Okay, minus 4 by 5, 1 by 5 minus 4 by 5, you get it as an minus 3 by 5. Sorry, here minus 3 by 5. That means in the first case we got LHS as a 1 and RHS we got as a minus 3 by 5. Both are not equal. So we can say that collection of rational numbers does not follow some associative property under subtraction. So subtraction is not associative for rational number. Subtraction is not associative for the rational number. Now let us see the associative property for multiplication. Let us see the associative property for multiplication. What is associative property for multiplication? Says that means for any three rational numbers a, b and c, we have a into b into c is equal to a into b into c. That means if you change the group of the numbers while doing the multiplication, then also you get the same answer. That means even if you change the group of numbers while doing the multiplication, then the answer remains the same. That's why we say that collection of rational numbers follows associative property with respect of multiplication, or else multiplication is associative for rational numbers. So let me explain with an example, that is of a is equal to 5 by 3, b is equal to 4 by 7, c is equal to 3 by 5. If you take a into b into c is equal to 5 by 3 into 4 by 7 into 3 by 5. Here 4 into 3, that is of 12, and 7 into 5, that is 35. That means 5 by 3 into 12 by 35. Okay, 5 ones are 5, 5 sevens are 35, and 3 ones are 3, 3 fours are 12. Then you get it as an 4 by 7. And if you take a RHS a into b of into c, that means a into b into c, that is of 5 by 3 into 4 by 7. This product should be multiplied by 3 by 5. That means 5 fours 20, 3 sevens are 21. 20 by 21 into 3 by 5. 20 into 3, okay, by 21 by 5. Okay, 5 ones, 5 fours, 3 ones, 3 sevens. That is of 4 by 7. That means if you change the order of the numbers while doing the multiplication, if you change the group of numbers while doing the multiplication, then also you get the same answer. That's why we say that multiplication is associative for the rational numbers, and we can say set of rational numbers or collection of rational numbers follows associative property for multiplication. And let us see about division. For a division, so collection of rational numbers does not follow the associative property for division, because a divided by b of b divided by c, which is not equal to a divided by b, which of divided by c. That means on changing the group of the numbers while performing the division, then that change the order, that answer effective with the groups, okay, while performing the division. That's why we say that collection of rational numbers does not follow the associative property for division. So let me explain with an example. A is equal to 4 by 7, b is equal to minus 5 by 2, then c is equal to 5 by 3. Then you get it as an a divided by of b divided by c, you get it as an minus 32 by 105, and if you take a divided by b whole divided by c is equal to minus 24 by 140. So as these two are not equal, we can say that collection of rational numbers does not follow the associative property with respect to division. And if you revise associative property, we can say that collection of rational numbers follows associative property with respect of multiplication, with respect of addition and multiplication, and it does not follow commutative property with respect of subtraction and with respect of division. Okay, so this is what brief explanation regarding the associative property.